So in this presentation, we'll just go over the solutions to this first set of practice problems with arrow in. Looking at the first one, so remember that our process is typically the same. Actually, it's always the same for every proof. We start off the same way. We list our premises in the first lines, and then we look at our conclusion. So here are premises, then let's look at our conclusion. What's the main operator in this conclusion? Well, the main operator is the arrow. So I have two sides to the arrow. And remembering our rule for arrow in, whenever we have an arrow statement as our conclusion, we should look to assume the left-hand side is a PA, mark it as an assumption, a provisional assumption there, and then we're looking to prove T with what we have already at our disposal. So, what do we have, or where is our T? Our T is here. So we know we're going to have to get that arrow out. So the arrow is bound by this antecedent here. And I don't have it in my proof, so I'm going to need to build it. Luckily, I've got both the pieces that I need. I have P and Q. So I can put them together using my ampersand N. And so 2 and 3. And then I have my antecedent here that I can toss in. And then I can get the T out from that conditional statement. So that's going to be 1 and 4, arrow out. 1 is next to 1, 2 and 3 are next to 4. Now I've got my consequent to the conclusion that I was looking to draw, this conditional statement. So since I have my conclusion, it depends upon my PA right there. So I see the 3 that's in there. So because I meet those conditions, I can write my conditional statement as 3, which is where my PA is at, 5, where my consequent is at. What am I doing? I'm introducing an arrow. So that's going to be 1, 2, and 3. But since I did arrow in, I dropped this 3. This 3 goes away. And so the only numbers that I have are 1 and 2 here at line 6. So real quick, looking back through, we had our assumptions. We recognized that a conditional statement was our conclusion. And then what did we do? We assumed the left-hand side, the antecedent in line 3, and we looked to find the right-hand side or derive the right-hand side in our proof. And so that's what we did in line 5. And then since we had the left-hand side as a PA and we got the right-hand side as a derivation, we could use arrow in to link them up. And so we did that. And then we just dropped out the premise that's associated with the PA. Moving on to the second problem, what we have here is one premise. And then looking at our conclusion, same thing as before. We've got a conditional statement as our conclusion. So we're going to assume the left-hand side. We're going to mark it as a PA. And then we're going to look to prove the right-hand side. So we're looking to get to Q. So looking at what we've got conditional statement 1. Do we have its antecedent? We don't, but can we make it? Well, it's just a wedge. So we can wedge in the P with our T. So we could do P wedge T in 2, or sorry, in 3, doing 2 wedge in 2. And then that gives us our antecedent, so we can get Q in line 4. So here is our antecedent in line 3 that we can toss into here. And we can kick out our consequent down here in line 4. So that's going to be 1 and 3, arrow out. 1 and 3 gives us 1 and 2. And then now we've reached our consequent that we were looking for up here. And we've got our PA here. That consequent depends upon the PA. So we can write T arrow Q doing 2, which is our PA, 4, which is our consequent. What are we doing? We're doing arrow in. Numbers 1 and 2 are next to those, but what number is our PA? Our number is 2, so we'll get rid of the 2 here in line 5 after we do our arrow in rule. So just remember, whenever you do arrow in rule, and then once we get to tilde in, tilde out, that will also be another instance. But if you ever do the arrow in rule, you have to mark out a PA in the same line in which you cite it. But this is our second proof. Moving on to 3, we've got our 2 premises. We've got Q and T, and we've got S arrow P. Now let's look at our conclusion. Our conclusion is a conditional statement. So since our conclusion is a conditional statement, that means we've got our antecedent here. We've got our consequent on this side. So we're going to assume the antecedent here in line 3, which is S. We're going to mark it as a PA. And then we're going to look to prove P and T. Well, based on what we've got, let's look at what we can do. I've got a T there in line 1, so I could get the T out, because remember I'm looking for P and T by themselves. So I can get T out of 1 by doing 1 ampersand out. So that gives me my T, so I just need to get my P now. So I can get my P by putting my S into here and then getting the P to drop out in line 5. So that would be 2 and 3, arrow out. And then so 2 and 3, 2 and 3. And now I've got P and I've got T, so I just got to put them together in line 6. Clean some of this up real quick. So now I've got to the consequent that I was looking for. I've got to my antecedent here, and I made it a PA. So in line, oh, sorry, I guess I should finish this line 6 real quick. So that'd be 4 and 5 ampersand in. Then 4 and 5 are 1, 2, and 3. But now I've got to my consequent in line 6. I've got my PA in line 3, so I can write the conditional statement like so. Doing 3 and 6, arrow in. And then the numbers associated with 3 and 6 are 1, 2, and 3. But we're going to look at our PA and we're going to knock it out there. So the only numbers that are left are just 1 and 2. So clean this up real quick. And this is the proof for number 3. Number 4 is going to look like the previous problems as well. It just looks a little bit more complicated because there's a couple extra moves in here, a couple extra terms, but trust me, it's just about the same exact proof as the ones previously, and you're just going to follow the same sort of pattern as we've been doing all throughout. So you start with premises here, mark them as assumptions, 1 and 2. Then looking at our conclusion, I've got a conditional as my conclusion. So we're going to assume the left-hand side here as a PA. And then we're going to look to get to R by itself. We can see that R is right here. So we're going to have to get this conditional statement out. I've got one part of that conditional statement. I've got the P, but I don't have the S yet, and the S is attached to this other conditional statement. So let's deal with what we can do, and that is try to get out the conditional statement in one. So what's the antecedent in the first statement? Well, that is a P or Q. I don't have P or Q anywhere, but I can build it because I've got P here and 3. So I can wedge in the Q, doing 3 wedge in. And then I have my antecedent that I can toss into here. And then I can write my consequent down here in 5. So T and S. So 1 is my conditional statement. 4 is my antecedent. What am I doing? I'm doing arrow out. 1's associated with 1. 3 is associated with line 4. So there's that. Now, I've got T and S. And remember, I'm looking to get this R here in the second line. Well, to get the R, I need the antecedent to that conditional statement. The antecedent is S and P. So that means I need S and P somewhere in the proof. As I mentioned, I've got P by itself. So I just need to get S by itself. And then I'll build it together using my ampersand in. So I can get S by itself here in line 6 by doing an ampersand out in from line 5. Line 5's got 1 and 3, like that. And then now I've got P in line 3, S in line 6. So I can build that statement, doing my ampersand in. Still just 1 and 3. And then, now that I've built my conjunction, I can toss it in up here, and I can get my R out in line 8, doing 2 and 7, arrow out. And that's going to be 1, 2, and 3. 2 next to 2, 1 and 3 next to 7. And now I've got my consequent of my conclusion. I've got my PA here in line 3. That consequent depends upon the PA, so we'll do P arrow R. 3 is my PA. R is in line 8, so that's my consequent. What am I doing? I'm doing arrow in. That's going to have 1, 2, and 3 next to it. What number is associated with my PA? Well, that's number 3, so that drops out. And so that is all that we have left. So again, what we're doing is following a pattern. Our pattern is list our assumptions. We recognize our conclusion is a conditional statement. We assume the left hand of our conditional statement, and we look to derive the right hand of that same conditional statement that's in our conclusion. So once we do that, we can build our conditional statement that we're looking to prove, and then we just drop out the assumption associated with the PA. Now on to problem 5. So we've got our premises P and Q, arrow T, and we got just Q. Then let's look at our conclusion. Our conclusion is an arrow. So we want to assume the left-hand side as a PA, and then we want to build the right-hand side, and then we can arrow it in. So looking at what we need here, so just treat this as our new conclusion. That's what we're trying to get to. And what's the main operator in that statement? Well, it's a wedge. So if you remember, whenever we're looking to prove a wedge, we just need one of the disjuncts, and then we can wedge in the other one. Well, S arrow T, we're probably not going, or S arrow R, we're not going to get since there's no S or R anywhere in this proof, but we do have a T in our conditional statement in line 1. So let's try to derive that, and then we'll wedge in the other half of that disjunction. So what can I do to get the T? I need to do arrow out. I've got an antecedent here. I don't have it in my proof just yet, but I can build it with what I've got from 2 and 3 ampersand n 2 and 3. Now I've built the antecedent to my conditional statement. I can kick out my consequent down here from 1 and 4 arrow out. And that's going to be 1, 2, and 3. Then as I told you before, we were just looking to get t, and then we can wedge in the other part that we are needing. So that's going to be from 5, wedge in. 1, 2, 3. And now we've got to our consequent that we are looking to build. We've got a PA here in 3. That consequent depends upon that PA, so we can just arrow it in. Like so. 3 is our PA, 6 is our consequent. We're doing arrow in. We're going to cite all the premises, but then we're going to drop out the premise that's associated with the PA because we did arrow in. And then that is all that we needed to do. Now moving on to 6. It's a little bit longer, but it's just following pretty much the same exact rules we have been doing in the previous examples. So we have these two assumptions that were given. We have a conditional statement as our conclusion. So we're going to assume the left-hand side as a PA. And we're going to look to create the right-hand side. So to create the right-hand side, we're going to look to make all these ampersands. So we need S and P, which means we need to find S by itself, P by itself, and then we need to add Q in to those. So really we're looking for S, P, and Q, and then building in the ampersands the way that we need them to be listed. So what we're going to do is start off looking at our assumptions. Well, in line 1, I could separate my P and Q using 1 ampersand out for both instances. Both of them will cite line 1, and look, I've got P, I've got Q. So now I just need to get S by itself. So S is attached to that conditional statement there in line 2. Do I have its antecedent? Well, I don't just yet, but I do have one of the disjuncts that I could wedge in. So I've got R in line 3, so I could wedge in T, doing 3 wedge in, like that. Now I can toss this R or T into the conditional statement in 2. So I can take this, I can kick it into there, get my S out down here, and that's going to be from 2 and 6 arrow out. So we've got 2 is next to 2, 3 is next to 6. Now we've got our S, so we just need to build everything the way that we need it to be built. So we need the S and P together first. S and P, P is in line 4, S is in line 7, do an ampersand in. 4 has 1 next to it, 7 has 2 and 3. Then we need to add in our Q. And that's going to be 5 and 8, ampersand in. And so that's going to be 1, 2, and 3 again. And now I've got my PA in line 3, which is R. I've got my conclusion that I was looking, or my consequent, which I was looking to derive in line 9. So that's going to be 3 and 9, arrow in, 1, 2, and 3, but our PA gets dropped out, so it's no longer there. And that is this proof. So again, looks daunting from the outset, but doing each thing step by step, it wasn't that bad. We just had to break down the S, P, and Q, and then build it back up. And then once we built it back up, we had everything that we were needing there. So that is problem 6. Moving on to 7, we actually did this in the introduction to the arrow in rule. So hopefully you got this right when you practiced it for yourself. So remember, we're going to write these first two as assumptions. Our conclusion is a conditional. So we're going to write the antecedent here in line 3. We're going to mark it as a PA. Then we're going to look to derive our consequent from our conditional statement there. So we can take our P, we can toss it into here to get our Q. So that's going to be 1 and 3, arrow out. And then 1 and 3 over here. Then we can take, oops, didn't mean to be a P, should have been a Q. So then we can take our Q, toss it into here, get our T down here. So that's going to be from 2 and 4, arrow out, 1, 2, 3. Now we got our consequent that we were looking for in our conclusion, and we got our PA in 3, so we can build it there using our arrow in rule. So that's going to be 1, 2, and 3. And then, oops, getting ahead of myself there. Get rid of the 3 because we did the arrow in rule. And so that is this proof. Remember, or I think I mentioned it in the previous lecture, that this is usually called the chain rule. We don't do any derived rules in here because we don't do any super difficult proofs. We stay pretty mild in here, so I don't really teach you the derived rules. But this is usually the chain rule because it says if you have two conditionals that sort of collide into each other, as the consequent of one conditional is the antecedent of another conditional, if you can prove that you have the first antecedent to the first conditional statement, and then you know you can get to the last consequent of the last conditional statement, and then you can just squeeze it together with the chain rule. But this is the longer hand version of that. Moving on to 8, we've got conditional statement here as one assumption. We got another conditional statement as our second assumption. 2 assumptions, 1 and 2. Let's look at our conclusion. Our conclusion is a conditional statement, so we're going to assume the left-hand side in 3, and we're going to look to get to our conclusion or our consequent there, which is just L. So we'll put Q here, mark it as a PA, associate with 3. We're looking to get to L, and we see it there in the second conditional statement. We can't get to that until we work the T out of the first conditional statement. So looking at the first conditional statement, we have P or Q, so we can wedge in the P with this Q. Doing 3, wedge in. Then we can take this, toss it into our conditional statement up there, get our consequent down here. So that's going to be from 1 and 4, arrow out. 1 and 3 are associated with those. Let's clean this up. Now we've got T. So our conditional statement in 2 is T or S, so why don't we just wedge the S in to the T. So that's going to be 5, wedge in. 5 has 1 and 3. Now we're going to take this, we're going to toss it into our conditional statement up there in 2. So we get R and L. So that's going to be 2, 6, wedge out. Or sorry, not wedge, arrow out. And then so that's going to be 1, 2, and 3. Now we're looking for just L by itself, so we can just remove this L from this ampersand. So that's going to be 7 ampersand out. 7's 1, 2, and 3. Now we've got to our consequent and our conclusion. It depends upon our PA, so we can write Q, arrow, L, from 3 and 8, arrow in, 1, 2, and 3. The 3 drops out because that's our PA, so we don't need it, just like that. So that is problem 8. Moving on to problem 9, this might look a little bit daunting, but really it's just similar to a lot of the proofs that we've already done, just a couple of extra steps. So we've got our two premises here. That we'll mark as assumptions. Looking at our conclusion is a conditional statement. So we're going to assume the R here in line 3, and then we're going to look to get to S, our consequent of our conclusion, and then we'll build the arrow from there. So based on what we've got ampersand in line 1. We could break that all the way down. We got a conditional in line 2. We don't have the antecedent to that conditional, but we could easily get it if we just take the t out from line 1. So we'll take the t out from line 1. And then we could put them together. We could put the R and T together, but we got to put them in the right order. R and T by doing 3 and 4, ampersand in. 3 and 4 have 1 and 3. Then we can take this, toss it into our conditional statement in line 2 to get our consequent, our P arrow S, from 2 and 5, arrow out. Let's see, 1, 2, and 3. Then we need to get this S out. That's the whole goal. So we need the P to get the S out. So we're going to have to separate the P and Q from line 1. And then we need the P by itself. So we'll separate that out from line 7. And then we can toss it into our conditional statement to get our S. So that's going to be 6 and 8. Arrow out. 6 and 8 have 1, 2, and 3. So now we've got our consequent to our conditional statement and our conclusion. It depends upon our PA from line 3. So I can write R, arrow, S from 3, 9, arrow in. That's 1, 2, and 3. We'll drop out the 3 because we're doing arrow in as our rule. And that is our 9th problem. Now for problem 10, we got something a little bit different. And it's just to drive home a point about what we're doing when we have a conditional statement as our conclusion, which is that we need to assume everything on the left-hand side. So here, this is our antecedent. This is our consequent. We're going to assume everything on the left-hand side and put it here on 3. It's got to be the exact thing that appears in our conclusion. So we're going to mark that as a PA. And we're going to look to get our consequent, which is just T by itself. So we can break apart our Q and P in lines 4 and 5. 4 and 5. So that's 3 for both of them. And then we can put them back together the way that we need to for our conditional statement. So we'll put P and Q together for 4 and 5, ampersand in. So still just 3. Now we can chuck this into our conditional statement in line 1 to get S. So that's going to be from 1 and 6, arrow out, 1 and 3. And then now that I've got S, I can toss it into my conditional statement and 2 to get T by itself. So that's going to be 2 and 7, arrow out. 1, 2, and 3. And now I've got my consequent, which is t by itself. I've got my PA of Q and P that it depends upon. So I can write Q and P, arrow T, from 3 and 8, arrow N. It's going to be 1, 2, and 3, cutting out that other 3 there. So it'll just be 1 and 2. So that is problem 10.